Okay, we're going to go ahead and start with 2.1, using graphs to relate two quantities. Before we go into what are functions and how we use functions in mathematics, we're going to start with the basic idea of finding a relationship between two things, two variable quantities. So that's going to be our key understanding for today. We're going to be looking at how do we use graphs to visually represent two variable quantities. Our first problem says the graph shows the volume of the air in the balloon as you blow it up until it pops. What are the variables? Describe how they are related at various points on the graph. So what we're going to do is we're going to analyze this graph and describe what are the variables. Alright, so we're looking at the variables. The variables are going to be right here. They're going to be on the x-axis and on the y-axis. So the first thing we know is that the variables are volume and time. Now, to describe what is happening, okay, so we want to know what is occurring in this graph. How can we describe this? You are blowing air into that balloon until it pops. So what you see here is you're blowing air, going up, and then there's a pause. You need to take a breath. And then you blow more air into the balloon, and then you take a breath. You blow more air into the balloon, and you take a breath. Blow more air until eventually you can't fill any more air, and the balloon's going to pop, and so therefore the volume of that balloon goes to 0. So what you're noticing is an increase of the volume of that balloon until eventually pops and there's no more volume. Okay, and that's an extension of time. As time goes by, that's what you're seeing occur in the balloon. So if we're to describe the situation, we're going to say that the volume increases each time you blow and stays constant each time you pause to breathe. So that's an example of how to describe and determine the variables of this graph. For problem 2, we're going to match a table and a graph. A band allowed fans to download a new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days, given right here. Which graph could represent the data shown in the table? So we have a multiple choice here of which one of these tables can fit the data. So what you want to do is every single day there's a change of +1. But let's look at the total downloads. That's what's going to tell us what's really occurring on the graph. So for total downloads from 346 to 1011, it is increasing by 665. Then following day, from day 2 to day 3, we had an increase of 2,444 downloads. And from day 3 to day 4, we had an increase of 6,971. So if we look at what's happening to the downloads, it is not decreasing, it is increasing. So therefore, we can eliminate D. And it continues to increase, so there is no plateau, so C is out. The increase changes quite dramatically, almost exponentially, so it is not constant. So that wouldn't fit table A. So our best solution that would fit this scenario would be B. So the answer would be B. You can see from the graph how this is exponentially increasing under downloads day by day for the group. Okay, now for problem number 3, sketching a graph. We want to read this problem and make a graph that fits the scenario. A model rocket rises quickly, so I'm going to go ahead and highlight rises quickly, and then slowly slows to a stop. So it's going to go to a complete stop as its fuel burns out. It begins to fall quickly until the parachute opens. So it'll begin to fall, and after the parachute opens, it will then after which it will fall slowly back to Earth. What is a sketch of a graph that could represent the height of the rocket during its flight? Label each section. So here I highlighted the important things. The rocket rises quickly, then it slows to a stop, and then it begins to fall quickly. Once its parachute opens, it will slowly fall back to Earth. So this is what you will likely see as in the description of what we're looking at. So At time 0, the rocket quickly starts to go up as time starts. Then as it quickly rises, it runs out of fuel, which is where we're right here where it stops rising, and then it starts to fall quickly back to Earth. At that point, a parachute opens, and then what we have is the slow decline, and it falls slowly back to Earth with the parachute.